Hey guys, so before we start the next lesson, I thought it would be probably a good idea to do a quick warm-up to make sure you remember your limit rules. So we're going to use this little graph over here to help us answer each of these questions. So first question is find the limit as x approaches -3 plus, which means from the right side. Here's -3, we're approaching from the right side, so this is getting us closer and closer to a y value of 3. Quick reminder, the limit doesn't mean what does it equal at that value. It means what are you getting close to. Okay, so even though there's an open circle here, I know that means it doesn't really exist at 3, but the limit's asking what are we getting close to. So it's getting closer to 3. -3 from a negative side, the left side, would be -1. We're approaching the -1y value. The limit as x approaches 4. Where is 4? Okay, so here's 4. And I kind of drew this graph to see if I could trick any of you with this open circle, closed circle situation. So if I say, what's the limit as I am approaching 4, means you're going to come from both directions and you're going to tell me what you're getting closer to. Not what the filled in circle is at, what you're getting closer to, which is -3. Find the limit as x is getting closer to 0, which means here on the y-axis, that looks like +3. And then f of 4, and this again is a trick question. So this is not a limit. This is just what is the y value when x is 4. So when x is 4, the y value or the filled in circle is located at 1. So the difference between, this is just asking like an ordered pair versus the limits are asking what we're approaching. Okay, so what we're going to be doing today is lesson 7.3, and we're going to be going through more limit questions that specifically focus on limits as you're going towards infinity or limits where graphs go to infinity. Okay, so the first chunk of our lesson is going to be us drawing graphs to model the given situation. And all of these situations are going to have limits that are asking us to approach a value c, where I just want you to understand c is just a random value that was chosen. I'm choosing to put c over here. That might be 5 on the x-axis. It might be 1. I don't know. It's just I'm picking a spot and calling it c. So sketch a graph to demonstrate each of the following. So we're saying if I am approaching this value c from the left side, and if the limit goes to infinity, what would that look like? Okay, and there's a lot of different answers. I'm just letting you know. A lot of different answers, but we're going to just draw like one scenario. So if I'm approaching c from the left side and my graph goes to infinity, that would mean I would have a graph that is going up the closer we get to this line C. It would not be crossing because you are just approaching C from one side. This is not necessarily a smooth curve, could be like a very wavy, weird graph. It just, the key point of this is that as I get closer to C from the left side, I'm going up to infinity, okay? On this one, what if the graph was approaching C from the left again, but was going to -infinity? So that could be, again, like some weird wavy graph maybe, but then the closer that we get to C, we start to go down to infinity, -infinity, sorry. Okay? Let's do the same thing, but from the right side. So what would it look like if I was approaching C from the right side, but it goes to infinity? So again, my graph could be doing some weird wavy thing, but it would be going up to infinity, not crossing that line ever. And then again, if I'm approaching C from the right and go to -infinity, what would that look like? Go to -infinity as I approach from the right. By the way, those are supposed to be straight lines. I just can't draw a straight line using this tablet thing that I'm using. So I promise there's a point to all this. I just want to go through some more examples and then I'll summarize all of this graph drawing for you. So next we want to draw the limit as x approaches c as the function of the function as it would equal infinity. So as I'm approaching c, not from the left or from the right, but from both directions, what could that look like? So like in my mind, I feel like you've got to have both sides going up to infinity the closer you get to c. So it would have to be something like this, right? And then on the next one, we're going to do the same thing, but we're going to go to negative infinity. So I would have to draw something that would be going down to negative infinity the closer I get to c. With me? Does it make sense? Okay, I think I just have two more. So these last two are a little bit of a challenge. There we go. These are a little bit of a challenge because what we're doing is we are taking the limit as we go to infinity. So if I'm going to do as x approaches positive infinity, I want to take the limit as my graph goes to the right as far as it can. The L means that I want the limit to equal a number. Okay, so I want it to like stop at some point. So my graph is going to, if I'm going to infinity, it means the right side of my graph. So my graph will be doing something, I don't know what, but something down here. But if it's going to level off at L or some number, L means some number, then it's going to have to look something like this. It's going to have to level off on the right side of the graph. The next one is x approaches negative infinity, which means go to the left side of your graph. And again, we want it to level off at something called L. So it would have to look something like that. Okay. So now we want to do the same thing, but we want to not restrict ourselves to approaching the graph at a certain point. What we're going to do now is say, let's approach the graph as x goes to infinity, and we want the result to be infinity, the limit. So that would mean you would have, I don't know, graph doing something, something, whatever. But then when you get farther to the right, your graph is going to continue to increase upward toward infinity. The next one is I want to approach negative infinity, which means the left side of the graph, and I want the limit to equal infinity. So that means as I go, whatever, I don't know what this is doing, but as I go to the left side of the graph, my function is going to continue upward. By the way, aren't these graphs amazing? Okay. Two more. So we're going to do the limit as x goes to infinity, so right side. The function goes to negative infinity, so that would be like your function is going down the farther right you go. And then last one is x goes to negative infinity, the function is going down. So that would be going to the left, your function is continuing to decline. Summary. So what we've done is we have, whether you realize it or not, sort of created definitions for asymptotes. So an asymptote is an imaginary line that your graph can never cross. Limits can be used to define when an asymptote will occur. So here's situation number one. You will have a horizontal asymptote when you take the limit to infinity and you get an actual number as an outcome. So When you take the limit as you go to infinity or negative infinity, you get some finite number as your outcome. That means that your graph is leveling off at some point, and the only reason it would level off at some point is if there is an asymptote there. Definition number 2, you could have a vertical asymptote if you take the limit as you're approaching some value and you get positive or negative infinity out of it. Okay, so if you're approaching a value like we did at the beginning of those graphs, and you are going up to infinity, the closer you get to this value, the only reason that that would happen is if there was an asymptote right at that value. Okay, so I would ask you, if this doesn't make sense, refer back to the graphs that we made and see if you can visualize it that way.